In this video, we'll be talking about addition and subtraction. In the first semester, we'll be working with facts within 10, and in the second semester, we'll be working within 20. There are many TEKs that are covered underneath addition and subtraction. It's kind of broken into two parts where we'll be looking at, in this first video, just about basic facts, and in the second part of the TEKs, for the rest of the days, you'll be working with word problems and actually applying those fact strategies that the students will be learning. So to start out, we'll be focusing on TEKs 1.3c, 1.3d, and 1.3e. We will also be working with TEK 1.5e, 1.5f, 1.5g, and within all of this, we'll also be incorporating TEK 1.3b. First thing we're going to look at is sort of a progression of how students go through attaining their math facts: addition, subtraction, multiplication, division. We're going to look for addition and subtraction, that they're going to start out with counting. Students are going to use their fingers. They're going to use strategies of counting on. What we're going to be working on in first grade is moving them from that counting, where if I have 3 plus 2 more, that the students in this very early phase are going 1, 2, 3, 4, 5, and that's how they're doing their adding. As we work through in first grade, we're going to be working with the students on reasoning, and we're going to be giving them strategies that they can use to rely on later on. Students in first grade do not have to know their facts with automaticity. If you'll notice here, that's where second grade is going to end up. They're going to be working on these reasoning facts and working towards automaticity. We want students to be flexible in their thinking, and what we're really doing is laying a foundation for students to have strategies to fall back on when they don't know something automatically, without having to jump all the way back to counting on their fingers in order to do their addition. When working with addition and subtraction strategies, we don't want to just start with 0 and move the students on, then 1s, then 2s, then 3s, then 4s, then 5s, and so on. But we want to sort of chunk the strategies together, or chunk the numbers together, and so we're looking at strategies. So we're talking about adding +1 or +2. Another strategy is adding 0, using 5 as an anchor, making 10, doubles and near doubles for addition. We're going to specifically talk about the importance of the benchmarks, which is the using 5 as an anchor and making 10, using 5 and 10 as benchmarks. Subtraction strategies are going to be think addition, fact families, build up through 10, and back down through 10. You can find more information on the instructional talk pages about each of these different strategies. We're just going to really focus on the two that are really important and vital for later on when the students are doing more than just fact addition, where they're adding things like 37 plus 28 or something like that. They can use these benchmarks, the using 5 and the making 10, to help them. We still want to have the students use manipulatives when we're working with our basic facts. That's how we want them to start out. We don't want to just jump to giving them worksheets with addition or subtraction problems on there and just having them fill out answers. We want them to have something to manipulate. A thing that we can add to this is something that gives the numbers structure and allows the students to have a visual to go with it. So instead of only using the 2-color counters or the unifix cubes, if we were adding something like 5 plus 1, we could have the students build in a 10 frame that addition problem. We can have them put the 5 plus the 1 more, and it's just going to give them structure, allow them to have a visual to make an attachment to that, but they'll see that there's 5 plus 1 more. You could use the 2-color counters as well, and they could lay them out. So not only do we want to provide them with manipulatives, but if we have them building within something that gives structure to the numbers that they're working with. When we think about working with basic facts instructions, and we're talking about the different addition strategies that we're going to be using with the students, as we have the manipulatives pulled out and we're working through these strategies, we want to make sure that the students are practicing these various strategies. We as teachers are going to have to explicitly teach some of these strategies. Some students may come and just start making connections to what they already know, but a lot of times we're going to have to be very intentional about covering these strategies for the students. We can do that through the manipulatives, then through just number practice. We also can embed these strategies within story problems and be practicing them through that. It's just going to make everything seem more real, and not just these random numbers that keep popping up. As we're working, we can do some activities or some games. So one thing that we can do with the building towards a 10, or working with those benchmarks of 5 and 10, is a game called Make 10 Frame. So basically the students would have a 10 frame. They have a number that's provided for them or given to them by the teacher, and they would build with their 2 color counters the very first number. And so they can put that in there with red, or whichever color that they choose to start with. And then they would build using the second color until they have the 10 frame all the way filled in. And the students could then tell you that 4 and 6 make 10, and we would also want them to possibly have some type of recording sheet to where they could show that exact same information. The students could then get another card, another number card, build in the 10 frame, and record their information on a recording sheet. But this is just going to allow them the exploration. It's also going to allow them the structure with the 10 frame for them to be able to practice what is making a 10. Here's another activity called Towers of 10 that the students could do to practice working with the making 10, or that benchmark of 10. And the students just count out however many blue or whatever color, 2 color counters you have, and they would count those out, join the cubes together, and then they would add until they make a tower of 10. And then what's provided here is a sentence stem that you could model for the students, and they could draw their own towers and write the addition equation that they have to match each of these. But these are just activities that students could be doing in partners. These are activities that can be done whole group. These are activities that could be put in stations for students to practice with the benchmark of making 10. Okay, within the TEKS that we have, we want to make sure that the students are also working with the equal sign, and the important part of that is making sure that the students know that they have that the balance sign means that both sides are the same, or the equal sign means both sides are the same. We want to avoid having kids focusing on that the equal sign means and the answer comes next. So as students are reading through addition word problems, or they're working on subtraction, and they're working on a problem of 3 plus 7 is 10, we want them to say 3 plus 7 is the same as 10. We just want them to make those connections back, that that's what the equal sign means. It will help them later on as they get into algebra. The last part that we're going to just look at or talk about very briefly are the properties of operations. As teachers, we need to be very familiar with the commutative property and the associative property. Students do not need to know these two terms, but they need to be familiar with what these properties do. So with the commutative property, if we use that same addition problem, this is where the students get the idea of the turnaround facts. If I know 3 plus 7 equals 10, then 7 plus 3 will also equal 10. The associative property, when students have to add more than one number, I can combine whatever add-ins I want to and put those together. So I might know that 2 and 3 equals 5 plus 1 more is going to give me 6. If you have any questions about basic facts and how students can attain those, you can look at your instructional talk page, or you can contact us. Thanks.